Professor S.P. Mehrotra, Professor in charge Research and Development and Professor in charge External Relations at IIT Gandhinagar.
Good afternoon to all of you. Mr. Chairman, I would, with your permission, I'll digress for 2 minutes from my presentation to make a suggestion for DRDO. In fact, I should have made this comment in the morning sessions, but since I came a bit late and I think there was no time for that, so I will take this opportunity to make that suggestion. And this is with regards to the kind of relationship that DRDO should be having with academia in India. We have government-funded institutions, IITs, NITs, and several others. We have several quality private institutions, and we also have institutions not of high quality, both in government-funded category as well as private category. Now, as I see the concerns or needs of DORD, I can identify 3 modes through which DRDO can interact with the academia. One is directly linked with the HRD concerns. DRDO, like any other organization, would be concerned about the quality of manpower that it is getting now, or it'll get in future. So that's a major concern. And the manpower has to come from these institutions, good or bad. And therefore, it is definitely in the interest of the DRDO, like many other government agencies, that yes, the general level of academia should go up so that the output of these institutions is of certain quality. It is often said that 75% of our engineers coming out from the institutions are not employable. Okay? This number has to come down very substantially. So that is one concern. Then coming to immediate needs of defense, which DRDO in certain ways supposed to be concerned about. There are futuristic needs and there are present needs. Futuristic needs would need projects and problems, basically to establish proof of concepts. And then there are immediate problems or issues, technology not being available from other sources, or you want to develop your own technologies, and therefore you have to have interaction with the academia for technology developments. So I see 3 modes: product development or technology development, futuristic programs needing proof of concept, and HRD related issues. HRD related issues have to be tackled through projects, small projects to medium projects, which may not be of immediate use to DRDO, but they would help the institution in developing the infrastructure, motivating the faculty to create a culture of research in the institutions, and in the process try to motivate the students or make them aware about the R&D requirements, R&D needs, etc., etc. The proof of concept projects can often or normally come from people of certain competence. Not that everyone can do it, but yes, in our institutions, definitely in NITs and IITs, we have people who have tremendous competence and with their own efforts or with group activities may be able to establish the proof of concept. And these can be the projects which are identified by the DRDO on its own, or sometimes from the suggestion from the academia, and these can be funded to the individuals or institutions which may be of reasonable quantum. The third category of projects, product development is much more difficult. They do not come from individual efforts in most of the cases. They do not come often from single institutions. They come from networking. They come from the effort of consortiums. And these projects have to be in the mission mode. It is known, we have seen that there are several examples in Indian scenario that wherever the projects have been taken up in the mission mode, whether it's atomic energy, ISRO, or even in perhaps some of the mission mode projects of defense, the solutions have come. Indian scientists or Indian technologists have not disappointed, they have delivered. LCA is one example. It might have taken longer, but then yes, it delivered, and it delivered something which all of us can be proud of. How did it come? There were close to 100 institutions which were participated in one way or the other. There were a group of individuals who defined the problems, who defined the individual projects. They were then distributed, and then there was a group which synthesized the outcomes of all these projects and resulted in the final product. So there may be many products of or requirements of defense.
Professor, the general issues like this.
I'm just coming to an end. Okay? Look at my gray hairs. I've spent 40 years as professor at IIT Kanpur, director at NML, and I interacted with DRDO, DMRL very extensively. I know what are the issues involved. I can give you the list of, I'm going to give you the list of the topics that the faculty at my place are working on. It is not going to be different from the list that others have given you. I don't know how are you going to sort out which place you go to. In fact, the problem of Indian, not problem, it's a universal problem in fact, that in academia, if the problems are not defined, as a faculty member, we define our own problems. Most of the time, if you see the problem statement, they are identical.
This issue is very important, has been brought out before.
And we start at the same level.
Professor,
We almost, and give me 2 minutes, sir. I'm not going to take more than that. I'll cut down my other part. I'll leave the PowerPoint here. If you find any merit, use it. If you don't find, leave it. But let me make this statement because I feel about it. That we start at a particular same level, all of us. Whether in IIT, NIT or private institutions, we start, problem statement is most of the time same. We start almost in a similar way, reach the same level, we then leave it. And if you see how the science research is being done, taken from a level to this, the next level is missing in most cases. What is happening afterwards? Nothing, we don't know. So what is that we are doing? We are generating data research. Since I would be leaving to catch my flight, therefore I am making this observation. If time is dictated, as I said, I leave my PowerPoint here because I am going to say the same thing which others have said. Okay? Okay. Since you all have this information with you, so let me come to the. At Gandhinagar, we have identified 5 major areas which we think would be of some interest to DRDO. Okay? And as I said in the beginning, they are not going to be different or appear different from most of the presentation that you have already seen or you will be seeing in another 15-20 minutes time. Okay, materials. Within materials, you can have different kind of composites or advanced materials. Example, silicon carbide based. You can have functional material, high energy materials, nanotechnologies, nanomaterials of one kind or the other. The another sector where we have lot of activities going on and we think we have lot of potential, fuel cells, solar and wind energy, hydropower. And I think one major emphasis that one would find in IIT Gandhinagar is on integrated power systems. We have strong groups on sensors, optical type rangefinders, seismic sensors, sensor for disaster management, and gas sensors, particularly for sensing the hazardous and toxic gases. One unique emphasis that you would find, I'm saying unique because not many institutions in India are working on this area in the manner that IIT Gandhinagar is trying to work, is the safety. System safety, structural safety, and safety to natural disaster. I'll come to it in a minute, why I'm calling it unique. I'll just talk about it. Then we have several other areas in which activities are going on related to aerodynamics. We have strong groups working on advanced CFDs. We have a strong modeling group, mathematical modeling, computations, data mining, and playing with large data systems, 3D vision, etc., etc. Why IIT Gandhinagar? One thing that I can say is we are proud of our the kind of faculty that IIT Gandhinagar has been able to recruit. We right now have, as we call, career faculty members. These are the faculty members who would be, hopefully would be having their entire career at IIT Gandhinagar. These are the faculty members who have come from institutions like MIT, Harvard, Berkeley, Stanford, Cambridge, and Max Planck kind of institutions. Even the older IITs, even my own IIT Kanpur, they often feel envious of IIT Gandhinagar because of this. And there are faculty members who declined offers from IIT Kanpur and Bombay to come to IIT Gandhinagar. And these faculty members are hungry for challenging problems. And I think that is our strength. The problem statements may not appear to be different, but it is that hunger of our faculty which hopefully would make things different. I've already mentioned about it, 5 areas where we have strength, or we think that we can do something different. Already mentioned these. In materials, I don't have to say we work in metals and alloys. In fact, I am myself a metallurgist. Composites, non-materials, non-metallic materials, biomaterials, and different, within each of these different categories you will find. Since we have fairly strong group in materials, a lot of activities in different types of material development studies, their applications are going on. This is one possible DRDO project. I think it is being discussed with some of the DRDO lab, and it is advanced stages of final decision. Terahertz with CMOs, inexpensive THZ detector for defense application, and the other is on development of compact models for semiconductor devices working under cryogenic conditions. This project also is under discussion with one of the DRDO labs, thrust areas, solar cell fabrications and characterization. In fact, at Gandhinagar we have a fairly strong group working on solar energy materials development and also more efficient design of cells. And as I said, integration of renewable energy into power sources is one of the areas of our interest. We have very strong groups in electrical and chemistry, electrical engineering discipline and chemistry, which are trying to develop chemical sensing using tunable diode laser spectroscopy sensors and physical sensing using optical fiber and tunable lasers. There was some discussion about C4Is, command, control, computers and intelligence. And we have a group which is interested in it and is already looking at some problems. May not be directly relevant to it, but at least the expertise and the present information may be fine-tuned towards DRDO applications. VLSI design is one of the areas of interest in asynchronous circuit design, IP integration in multi-core systems, and neuroformic architecture. These are the three areas in which we already have some expertise, and a group of faculty members already working on it. As I said, safety is one of the areas of interest. 1 minute. This is actually a center, safety center. The only, at least in academic institution, there is none of this kind. And this center has been funded by an international organization, Underwriter Laboratory of Chicago, which is supposed to be the international authority in fire safety. And to begin, it was established with their initial support, but now it has drawn support from many other organizations. And the scope of safety has gone beyond fire safety. We are looking at system safeties as a whole, urban safety, plus many other things. Some of these perhaps may be of use to DRDO. Fire safety structure is one part of it in collaboration with our civil engineering group. Some of the ongoing activities with respect to safety are listed in this: system engineering, process safety, performance monitoring, sensors, structure, earthquake engineering, cognitive engineering, etc., etc. Other areas of interest, as I mentioned, we have very strong group on modeling and computational activities, flexible flapping, wing aerodynamics. I think this is one project which is going on. If I remember right, it is with in collaboration with ADA. Other areas of some of the other areas, including computer vision, is something that is of interest to our faculty. And strategic site detection of defense, integrating geotechnical engineering with remote sensing and GIS.
So can we conclude? Don't have much time.
Conclude it.
Very good.